Assalamualaikum and good day. My name is SITI MASTURA binti Muhammad HUSSAIN, and today I'm going to walk through you my FYP project, a location-based cardiac emergency system with artificial intelligence feature, or fondly called CES. So CES is a web-based system which includes the heart disease patient biomedical data, which is heart rate and ECG, along with the current location of the patient. The system will monitor patient from time to time and inform ambulance of the patient's current location in case of emergency. The system will prioritize and classify patient's condition. Hospital also will be classified based on the patient's location. So the problem statement, the problem that the patient struggle with are heart palpitations to monitor themselves in need of immediate medical attention, the difficulty to find nearest healthcare center during emergency or for consultation with doctor, and difficulty for the staff to classify and prioritize patients according to their emergency. The objective of CES are to monitor patient from time to time, to locate patient's location and find nearest healthcare center to them, prioritize and classify according to their immediate need of health, and for patient to make appointment with doctor. So this is the module diagram for CES. We have the location part where Google API is used to find the geolocation, which means the current location of the user, and to also detect nearby hospital according to that location of the patient. Also, there is the web and database module where there is the web server and database management, and there is also emergency module under this where patients are classified according to their need of medical attention. There is also account manager, so there is 3 types of account. There is staff, in this system is just admin of the system. There is patient, and there is also doctor account. Next is the module for classification, where this is the back end of the system, where the biomedical data and appointment are classified and prioritized using Python using rule-based classification. So this is the architecture diagrams. The system starts with the data collection. So if the data collection of the patient, staff and doctor, the user personal details, and then the biomedical data where the data of ECG and heart rate taken, and then the patient's current location also are taken, and then whether the patient wants to make appointment with the doctor. So this is integrated with the system, where the system will display all the personal details, will display the analysis of the biomedical data which are done using Python. Here is the biomedical data analysis classified, and also the appointment classification also is done here according to the role which patient wants. So the implementation, this is how the implementation are done by 4 phase, which started with the login page and dashboard for the early phase, and then each web page are done at the second phase, which is the account web page, the appointment web page, and the location web page. At the third one, they are more specified where the account, the personal account of the user are done, and then for the make appointment form and integration are done. Here is the core of the system, where the biomedical data were done at the last phase of the system, the biomedical data analysis, which is done by using Python, and appointment calendar means done by Python at the back end for the classification. This is basically how the system works. It starts with the login account, so only registered user can use this account because only heart disease patient can use this account. The data of either user are qualified or not is in the database, and then the staff will make an account for the user. Then the user can log in and prompt their general data, which means the personal details, and all the data are stored in the database. And then the data prompted also is the biomedical data, which is the ECG and the heart rate. When the reading is normal, how the reading is classified will be shown in the next diagrams. If the reading is normal, the system will halt, but if the reading is abnormal, it will send notification to the staff, and the staff at the staff dashboard, there is a notification alert where the staff will get the information of abnormal reading patient, and then the staff will contact the patient and ask them whether they want to visit the healthcare or not. If so, the patient will need to make appointment, and the classification apparatus are done, and they can make the meeting with doctor and make the. But if they don't want to make appointment, the system will halt. This is the classification and rule for the classification. When the biomedical data, heart rate and ECG is retrieved to the system, so the system will first rate either the heart rate is normal or not. If the heart rate is normal, it will take count as one abnormal heart rate, and if this happens 4 times in a row, it will alert the system. Also, if the same thing with the ECG reading, so the reading will be taken every hour, so the latest 4 reading is used to classify their priorities. Same goes to the ECG reading. If the ECG reading is normal, it will stop as a low priority if the both heart rate and ECG are normal. But if either of the reading is 4 times abnormal for both data, they will be classified as high priority. But if either of the data, let's say only the heart rate of the patient, all 4 is abnormal, but ECG is normal for the latest 4, their priority will become medium. So a patient with higher priority will get appointment with doctor. Let's say 2 patients ask for same time of appointment. If patient A have the high priority, patient B won't get the appointment for that time, and they need to make another appointment for that. So now we are going to see the demo for there are 3 type of user, which is staff, patient and doctor. So staff here acts as the admin for the system. Only the staff can register account for other users. So and this is the home page or main page for the staff. Here we can see the account. Here is the personal information for the staff. And then here is where staff can register another user to use the system. For now we have 2 types of patient, patient 1, patient 2 and also doctor. Staff also can manage appointment for patients, but basically the appointment is automatically done by the back end of the system using classification. And here is the emergency module, where if any patient is in emergency or in need of medical attention, their name and details will pop up to the staff dashboard, and the staff can contact the patient to know whether the patient needs help or needs any medical attention or need ambulance to be sent to them. This is the emergency notification, where only any patient that in need of help. Pressing here will go to the tab just now we saw. Okay, that is for staff account. As we saw in the staff account, there is 2 patients that exist in the system. So now we are going to log into patient 1's account. So the dashboard of homepage is the same with the staff, except they don't have the notification for emergency. Okay, at the account, this is personal information displayed of the account holder, which is the patient 1 account right now, and then the biomedical data. Okay, here is display of the latest 4 reading of the patient, of patient 1. So this is the latest 4 heart rate read. This is the latest 4 ECG reading. So these readings are retrieved from the existing data set. It is considered as the latest reading of this patient 1, and then the reading will go to the back end, which the Python where classification happens. So classification done here is using SIMS. So as we saw in the flowchart just now, the latest 4 reading is indicating normal, and also the latest 4 ECG reading also is indicating normal. This patient right now have a low priority. If in case in future this patient wants to make appointment, and if the appointment coincide with another patient, the other patient may have upper hand if they have a higher priority than this patient. Okay, so here the patient can make appointment using this form. Let's say we make an appointment for say for 3rd of July and 10 a.m. let's say. And then this will be input to the appointment calendar, or like just now, after filling in the form, it will redirect to the appointment calendar where they can add appointment over here, and the appointment request just now is in applied status right now, so the patient can either edit the appointment or even delete. So as you see, just like I said just now, if the patient wants to make appointment, but if other patient have the priority, this patient may get rejected. As you see here, on 23rd of June 12, they made an appointment for this time. So after this, you will see patient 2, and you will see why this patient is rejected and why patient 2 got the appointment. So this is the location part. So basically, the geolocation of the patient who logged into the account is identified using geolocation, which longitude and latitude of the patient is detected and then will be shown in the map over here. And if the patient wants to visit nearest hospital, they can press this button over here, or they can just go into tab here, nearest hospital. So we'll use this way. Okay, we'll go to the hospital near me. So according to my location right now, the system detects the nearest hospital to the patient right now. So as you can see, these are the nearest hospital that you can see. And if they want to go to the hospital, like let's say this hospital, they use this and can press, and they will redirect to the Google Maps. So all of these are done using Google Maps API. So using that Google Maps API, after retrieving the encryption key from the Google Maps API, the maps can be embedded to this system CES, and then the backend Google API will then detect the location of the patient and show in the so like we can back to my location, like it will detect back where is my location. Like right now my location is in Siswa Sarjana, so it detects my location. After is where is the find the nearest hospital just now we saw. Okay, so this is for patient 1. Keep in mind that patient 1 applied for appointment 26th of June, but didn't manage to get. So now we'll see why. We'll go to patient 2. So patient 2 obviously have the same GUI as patient 1 because they are in patient account. We'll straight go to the appointment to see that this patient 2 asked for appointment on 23rd of June at the same time, which is 12 p.m. and this patient had got approved. Why this patient had got approved is here. It happens in the biomedical data, as we saw in the classification flowchart I showed just now. This patient heart rate is normal. The last 4 heart rate is the last 3 before that was normal, but the last was in second stage of serious. The ECG reading is all 4 latest ECG reading was normal. So as the classification rule, this patient has the medium priority comparing to patient 1 who have a low priority. So this is why patient 2 got the appointment. That is how the classification happens. So all the other apps web page have the same function, like account, biomedical data, and location have the same function with the patient 1 because this is the patient module. The last module, the last account we're going to see, account user, is the doctor. Doctor have a much more simpler page display where the page is as the same as other user, and for the account they can see all the other account over here as same as the staff, and this is the personal account as all users have, and the biomedical data. The biomedical data over here shown is all the conclusion or the summary of all biomedical data analysis from the patients. So from here, the doctor can get to know, to learn more, and to always be aware of which type of heart rate reading is normal and which type is abnormal. Same goes to the ECG as you. And for the appointment, the doctor can see the appointment list that is approved by the system. So just now, patient 2 got approved for the appointment, so the patient personal data all is shown here. That's all from me. Thank you.